Hey guys, this is Mrs. Harbin, and this is section 2A.4 of Advanced Math. We are doing a quick mini unit on linear equations, and so far we have looked at the Cartesian plane, we have graphed lines, we have looked at slope, we have found slope from a graph, we have found slope from a formula. We have done a lot of different things so far with linear equations. Today we are going to look at writing linear equations. Take a look at this lesson opener. Let's find the slope of the line passing through the given points. You'll remember that slope is, our formula for slope is m equals y2 minus y1 over x2 minus x1. It's rise over run, which basically means we want how much it increases or decreases vertically by how much it increases or decreases horizontally, to the left or to the right. So let's go ahead and label these as x1, y1, x2, y2. We'll then write the equation and plug those in, and when we do that, we get 5 over 4. And when we do that for the second one, x1, y1, x2, y2, we take 3 minus negative 5. I don't know why I'm writing this right where the answer is going to appear, all over negative 8 minus negative 2. Use parentheses to protect those negatives, and what you get is positive 8 over 8 minus negative 2, negative 6. I can't see because I wrote on right on top of it. We would then reduce that to negative 4 over 3. Given the values of m, x, and y, let's find the value of b if y equals mx plus b. All right, this is our slope-intercept form, and so we want to find the value of b. So we're going to take y equals mx plus b and plug in what we know. We know that y equals 1. We know that m equals 2. We know that x equals 3, and we're trying to find b. And so we'll plug in what we know, and when we do that, we find out that b equals negative 5. Try the next two on your own and then check your work. In the second one, we find that b equals 5. And then the last one, we find that b equals 8. I am not going to work these out on the screen, but if you need help with any of these in particular, make sure you write them down and ask me when you get to class. Our biblical correlation from this unit comes from Job 38:5, where God says to Job, "Who marked off its dimensions? Surely you know. Who stretched out a measuring line across?" Job has been questioning God, and God finally says, "You didn't create the universe." Actually, he doesn't say that. He asks Job a bunch of questions. Who did this? And who did this? And did you do that? No, I was the one who did that. And we see this reference to measuring and dimensions, and we know that God is the God of math. He's a God of measurements, and he's created it for us, his created beings, to use to help take care of the creation that he has made. Our lesson objective for today is that you, the student, will write equations of a line given different features of the line. So far, we have graphed by making a table of ordered pairs. That was back in our first lesson where we had our x values. We had our function rule where we plugged and chugged to find our y values, and we found those ordered pairs. We've used the x and y intercepts. We know the x-intercept, our y is equal to 0, so we plugged in a 0 and solved for x. And to find the y-intercept, we know x is equal to 0, so we plugged in 0 for x and solved for the y-intercept. We also used the slope-intercept form, which is y equals mx plus b, using the slope formula that we just used a couple of slides ago. In this lesson, we will write the equation of a line if given slope and y-intercept, slope and a point on the line, or 2 points on the line, or the graph of the line. So we're going to be asked to write the equation. We're not being given the equation. We're just going to be given some information and have to work our way backward to find the equation of that line. Let's take a look at this example. Here's what we're given. We're given the slope, and we're given the y-intercept. So what we're going to start with is the slope-intercept form. We know our slope-intercept form is y equals mx plus b. We're then going to plug in what we know. We know that our slope is 2/3, so we change our m to 2/3. And we know our y-intercept is negative 5, so we change our b to negative 5. We could then write this in standard form if we wanted to. Remember, standard form is ax plus by equals c. In order to write this in standard form, we would want our x and our y on the same side of the equation, and we would want no fractions. If you would like to see that, actually, let's go ahead and show you how to do that in standard form. Not if you'd like to. Let me go ahead and show you. So if we subtract 2/3 x from both sides, we get negative 2/3 x plus y equals negative 5. Well, we want to get rid of this 2/3. We also want to get rid of this negative. So we're going to multiply everything here by the reciprocal, which is going to be negative 3/2. We'll distribute that negative 3/2 to all of our terms, left and right, and we get x minus 3/2 y equals 15/2. But we still have a problem. We still have that 2 in the bottom, and we want to get rid of that 2. So now I'm going to go ahead and multiply again and multiply by 2. And when I do that, I get 2x minus 3y equals 15. Now, this is just an extra step. I could have skipped this step entirely if I had just multiplied by negative 3 right here at the beginning. I could have done that as well, instead of multiplying by the negative 3/2. All right, so that was standard form. Let's take a look at example 2. Our given is that our slope is 3 and our point is 1, 5. Now, we don't know our intercept. Remember, our intercept would have to be 0 and then our y value. And this is not a 0, so this is not our intercept. When we know the point and the slope, what do? Well, we can plug in 5 for our y instead of for our b. We can plug in 3 for our slope and 1 for our x and solve for b. When we do that, we find that b is equal to 2. We can then go back to y equals mx plus b and plug in what we know. The 3 for slope and the 2 for the b. From there, we can leave it in slope-intercept form, or we could change it to our standard form, ax plus by equals c. In example 4, we're told that our slope is equal to 0 and our point is 1, negative 6. So again, y equals mx plus b. Let's plug in what we know. We know that y is equal to negative 6. Our slope is 0. Our x value is 1, and we're solving for b. We find then that using the steps of algebra, b is equal to negative 6. We'll go back to y equals mx plus b and plug in what we know, 0 for m and negative 6 for b, and we end up with y equals negative 6. We know that this is a horizontal line, y equals negative 6, that no matter the value of our x, here's our x-axis, y is going to be equal to negative 6, so no slope there. Let's write the equation of a line passing through 2 points. So here we know a point, actually we know 2 points, but we don't know the slope. So what's our strategy? Let's find the slope first. Our slope, remember, is y2 minus y1 over x2 minus x1. So let's go ahead and label our x1, y1 and our x2, y2. So we're going to plug in what we know, and we find that our slope is negative 5/3. From there, what can we do? Hopefully you said, let's find b by using y equals mx plus b. We know that we can use one of our xy points, so we're going to use this first one and plug in 3 for y, 1 for x. Our slope is negative 5/3, and now let's solve for b. We get 14/3 for b, so now we go back one more time to our y equals mx plus b, using our m and b to write the equation in slope-intercept form. We plug in negative 5/3 for our m, our slope, and positive 14/3 for our b. That is slope-intercept form. If we wanted to put it into standard form, we would want our y and x on the same side. With our constant on the right, we would want no fractions, and we would want a positive x term. The second point that we had, can be used to check your work, since it must be a solution to the equation. So we could plug in 4 and negative 2 back into the equation and see if in fact that does equal what it says it's supposed to equal. Let's write the equation of the line passing through 7, 4 and 7, 2. And we're given 2 points here, so what's our strategy? The strategy is going to remain the same as before. The first thing we need to find is our slope. And so we're going to do that by labeling our x1 and our y1, our x2 and our y2. We'll then plug in those values to our slope equation, or our slope formula. M equals y2 minus y1 over x2 minus x1. We'll then find the b by plugging in our slope and one set of coordinates, and use m and b to write the equation in slope-intercept form. Let's see what that looks like. When we plug in our slope, we find that our slope ends up with a 0 on the bottom. The slope of the line is undefined because there's a 0 on the bottom of the fraction, so the line must be vertical. Okay, if you're not sure what I'm talking about, y2 minus y1 over x2 minus x1, our slope is negative 2 over 0. That is undefined, so it's a vertical line. Okay, we can find that by plugging the slope, but we could also see our x value is a 7 both times. That's another hint that the line must be vertical. Our x equals 7. All right, here's a little something to help you with your homework. Parallel lines have, I thought letters would reveal. Parallel lines have, let's fill in some letters here, the same slope. Parallel lines have the same slope. So as you're working with problems, say, if you're asked to find a line that's parallel to another line, just remember, they run side by side and they never cross, so they must have the same slope. If two lines have different slopes, even if it's just slightly different, eventually they will cross. But parallel lines have the same slope, so they never cross. That should help you out with some of the work that we're going to be doing in class the next time I see you.